In this section on ANOVA for regression, we're talking about how we can actually think of doing an ANOVA type thing for a regression model, where what we're looking at as our two sources of variability is really the amount of variability that is explained by the model, or called our source being regression, sums of squares regression, and then the amount of variability that's not explained by the model, which is our error or residual source. So sums of squares error. And we can think of the r squared, which we said was the proportion of variation that is explained, by looking at the regression part, which is the good part, and dividing by the total variability. So in this problem, we're looking at a sample of 53 Florida lakes, and we have the average mercury level for a sample of fish and the pH from the lake. And so we're trying to see if pH is going to help us look at the average mercury level. So we have a scatter plot of the data, a normal probability plot of the residuals, and a partially completed ANOVA table, as well as a bunch of our coefficients and those sort of things. So we want to complete the ANOVA table and then use it to find r squared and interpret that value. So to get the ANOVA table completed, the first thing we need to do is the degrees of freedom. The degrees of freedom numerator is always going to be 1 for these problems because it's how many x's are in our model, and we just have 1. And the degrees of freedom denominator, or the error, is going to be n minus 2. And so that will be here 53 minus 2, which is 51. So we get 1 and 51, and those add up to 52, which is n minus 1. Then, just like we did in Chapter 8, when we want to get the rest of the table, we can take our sums of squares and divide them by their degrees of freedom. So divide that one by 1, and we get 2.0024. And then our, that's the regression one. And then our mean square error will be our 4.0455 divided by 51. And that one is going to be equal to 0.0793. If we add up these two sums of squares, the 2.0024 and 4.0455, they add up to 6.0479. F is the ratio of these two mean squares, so we can divide those, and we end up with 25.251, and if we go look that up in StatKey, we get approximately 0, and we use these 2 degrees of freedom. Okay, so to find r squared, we have up here that it's the ratio of these two values. So for this problem, I'll just write it up here. R squared is going to be the sums of squares regression of 2.0024. That's the good piece. We want that to be high. And then out of the total, it's 6.0479. So we're looking at how much out of the total do we get as the good piece, the explained piece. Here, this is 0.3311. So to put that into a percentage, it would be 33.11% of the variation in average mercury level is explained by the linear model with pH as a predictor.